Good morning, juniors. Today we're going to see the introduction to this topic by defining a very basic concept, which is a function, right? So we're going to see basically what is a function. So the objective for today's class is this one over here, know the concept of a function. So we're going to start by doing a very short problem, which involves handshakes. Imagine you're with a group of people and you want to determine a model that will tell you how many handshakes can be given depending on the number of people in a room, right? For example, if there are two people in a room, let's define a handshake like giving the right hand only, right? So if there are two people in a room, they can only give one handshake between each other, right? So here we would have one handshake. Now, if we have three people, let's try to make like a drawing here to understand what's happening. Let's say we have person A, B, and C. How many handshakes can be given in total when we have three people? Well, A and B, one handshake. A and C would give another handshake, and finally B and C would give another handshake, so we have a total of 3 handshakes here, right? So if there are 3 people, there are going to be 3 handshakes in total. Now, what if there were 4 people? Let's make our drawing again. A, B, C, D, A, B, C, and D. So we would have 1, 2, 3, 4, 5, and D with B, 6 right here, right? So we would have 6 handshakes in total if we have 4 people in a room. And we could do the same calculation for the rest, right? I'm gonna put the answers here already. If we have 5 people, you can try this on your own, but you would see that we would have 10 handshakes in total. And if we would have 6 people, then the number of handshakes would be 15. Are you noticing any patterns already? If we have 7 people, the number of handshakes would be 21. You can pause the video and try to do this on your own, and you'll see you'll get the same result. So, is there a way we can generalize this by looking at the pattern form here, in which we could find a model or a function which will let me calculate the number of handshakes when I have 100 people in a room? How many handshakes do you think we can have with 100 people in a room? So that's what we want to try to answer using the concept of a function, okay? So, in case you haven't noticed any pattern yet, I'm going to show you how to find the function or the model that represents this situation over here. So for that, what I'm going to do is I'm going to be calculating the difference. Let me do this with a different color. The difference between the terms, right? 3 minus 2 minus 1, sorry, that's 2. Then 6 minus 3, that's 3. Then we have 10 minus 6, which is 4. Then this is 5. And finally, this is 6. I'm going to keep on finding the subtraction between these terms until I get a constant difference. You see that if I calculate the difference between these two terms again, I'll get 1 here. 4 minus 3, that's 1. 5 minus 4 is 1. And 6 minus 5 is also 1. So you see that here I'm getting a constant difference between the terms. So there's a technique here which allows you to find the function or model that represents the situation by doing the following, right? I would say that if I had a constant difference here, this would be a function of degree 0. If the constant difference was found here, I would have a function with degree 1. And if I find the constant difference right here, I would have a model or a function with degree 2. We're going to see all these concepts later on, okay? So, since the constant difference was found here, where the degree of my function was 2, that means that my general function will be of the form f of x, we will see all of this terminology later on, equals ax squared plus bx plus c, which we'll see is the function of a quadratic function. You may have seen this already in previous years. So this is a function of degree 2. Why do we say degree 2? Because the maximum exponent of the x is squared, right? So I would need to find a model, a quadratic model, in order to generalize this situation right here for the number of handshakes. So how do I solve this? Well, I need to create a system of equations which will let me which will allow me to find the coefficients of A, B, and C. So in order to do that, I'm going to start by picking up any value of x. For example, x is equal to 2, right? So I'm going to plug in that into this function. I would say that f of 2, write this as f of 2, or maybe I'll do it the other way around. If I replace this value of x into my function, then I would have that, a times 2 squared plus b times 2 plus c is equal to f of 2. Whenever x, or the number, remember that x is number of people, right? And the value of the function would be the number of handshakes. So if there are 2 people in a room, I know that the number of handshakes would be 1, right? So this is equal to 1 right here. So if I organize this, I would have 4a plus 2b plus c is equal to 1. Don't worry, this is just an introductory example. We're going to be analyzing each of the concepts later on. I just wanted to show you what the importance of a function using this example. So then, if we work with x equals 3, for example, we know that the value of the function should be 3. There are 3 handshakes when we have 3 people. So doing the same process, this would be a times 3 squared plus b times 3 plus c is equal to 3. Okay? So if I organize it, we will have 9a plus 3b plus c is equal to 3. Okay, I would have to repeat this process one more time. Why? Because I have 3 variables. A, b, and c are my variables. So if I have 3 variables, I at least need to have 3 different equations in order to be able to solve this system of linear equations. Okay? So I'm going to use another value. For example, x is equal to 4. If I replace our model with x equals 4, we would have a times 4 squared plus b times 4 plus c is equal to, and if we have 4 people in a room, we know that the maximum number of handshakes would be 6, right? So organizing this gives us 16a plus 4b plus c is equal to 6. So there we have a system of, let me highlight this. I'm going to use this. A system of 3 equations, this one, and this one. 3 equations with 3 variables, which I'm going to show you now how to use a calculator to be able to solve this. So we're going to follow these instructions. Using the calculator, we're going to go to Menu, Equation, Simultaneous, and I'm going to show you this in a while. So if you take a look at the calculator now, we would go, well, menu 1 is our main menu where you can make calculations. I'm going to delete this. Delete. There. This is our main menu where we can find any type of calculation. But for now, in order to solve this system of equations, we're going to go to Menu, and you're going to go to Equation, the one right down here, right? Equa, you would see in your calculators. So you click on that, and we have different options. Simultaneous is this case where we have many variables and many system of equations, or a system of equations with many variables. Polynomial is when we want to find the roots of a quadratic function, for example, or of a cubic function, or whatever type of function. And solver lets you solve any type of function. We're going to see all of these functions later on. But for now, we're going to be using simultaneous. You may want to try this with your calculators as well. So how many number of unknowns? In this case, we have 3 unknowns, which are A, B, and C, right? So we're going to click on 3, which is F2. And then we have this system of equations, which is exactly the system which I highlighted here. The first equation, second equation, and third equation. So we're going to plug in the coefficients, the numbers in front of the variables, right? So for example, in the first case, we're going to have 4 is our value of A. B is 2. C is 1. If there's nothing written in front of C, we assume that there's a 1, right? As a coefficient. And the independent variable, the one on the right side of the equation, is 1 in this case, right? So that's our first equation. For the second one, we're going to look at the second equation we wrote, which is 9, 3, 1, and 3, right? And for the last case, we have 16, 4, 1, and 6, right? So here we have our system completed. So we're going to click on solve, which is F1. And you would see that we're getting here the three values of A, B, and C. The calculator always says X, Y, and Z, but we know that the first value is A, the second value is B, and the third value is C. Okay? So that's how you solve a simultaneous equation using your calculator. So let's go back to the assignment. The value of A, according to our GDC, is 0.5 or 1/2. We could write as 1/2. Then the value of B is -1/2. And the value of C is equal to 0. That means that we can now write the equation which models the number of handshakes as f of x equals 1/2 x squared plus or -1/2 minus 1/2 x plus 0, right? We don't need to write the plus 0 anymore. So this is the function that models the number of handshakes depending on the number of people. So now we can answer our initial question, which is, if we had 100 people, how many handshakes are going to be given? So we're going to say that if x is equal to 100, then this would be equal to 1/2 times 100 squared minus 1/2 times 100, right? So we can solve this using our calculators or whichever method you prefer. So we would get this value, 5,500 handshakes. So this is the number of handshakes that are going to be given if we have 100 people in a room, 5,500. Okay, so all of this example was shown for you to start grasping the importance of making functions, right? We are able to model different real-life situations using functions. In this case, we were able to generalize the pattern of the number of handshakes per number of people, and we're now able to find the number of handshakes for any amount of people instead of calculating each manually, right? Which will take a lot of time in case of 100 people in a room. We wouldn't be counting all of this number of handshakes. Okay, so that's basically what we're going to be covering during this topic, right? Functions. So here are some other examples where functions can be used. For example, here, how far will a car drive on a full tank of fuel, right? So we can model this using functions. Or is the relationship between runner and water the same as car and fuel? I don't think so, right? In the case of car and fuel, the greater the amount of fuel, the car will travel more, right? But in case of humans, if we drink more water, that doesn't necessarily mean that we're going to run more, right? If we drink too much water, maybe we'll feel sick and we won't be able to run anymore. Or, for example, this, can shadows be modeled using functions? Yes. We could do an experiment about this and find how the size of a shadow, for example, varies as time goes by, right? So some of the concepts and micro concepts we're going to be looking at during this topic: relationships, representation, then function, mapping, input, output, domain, range, composite functions, inverse functions, identity functions, one-to-one functions, self-inverses, and variables. We're going to be covering all of these different concepts. Okay, so let's start here by defining what a relation is about. It says, a mathematical relation is a relationship between any set of ordered pairs and can be expressed as a mapping and graph. We're going to see this right now. So take a look at this investigation here. It says, various relations are sorted into two columns below. Compare the relations in each column. So take a look at first part A in column 1 and then at column 2, and try to pick the differences between this set of numbers and this set of numbers. You would see that, for example, here in column 1, we get here, remember that points are given by x and y coordinates. So this is always the x coordinate, this is always the y coordinate. So you see that, for example, in this first column, here we have 3, 2, and here we have 3, 5. You see that the value of x is repeated, and we get two different values of y for the same value of x, right? And you don't see that in this case. In this case, all of the pairs of, all of the points are different, right? There's no repeated coordinate here. So that's a first difference you need to spot there. In part B, we see the same thing, right? One is repeated and it has different values of y in each case. And here again, 3 is repeated and it has different values of y in each case. While in the second column, column 2, we see that there's all of the x values are unique, but some y values are repeated. For example, 2 and 2 here, or 5, 5 here. So it's different from this situation in which the x coordinate repeated. In this situation, we have the y coordinate being repeated. So we're going to see the difference between that in just a second. Then, if we compare this to part C, these two mapping graphs here, we see that, for example, what's the difference? In this first case, this value of x, this input of x, is giving me various outputs, right? So for one value of x, I have different outputs. And in this case, for each value of x, well, there's a mistake here now that I see. Let me erase this for a second. For each value of x, there's a unique value of y, right? It's just a mistake from the book here. So let's assume that that 6 has only one solution there, which is 13. Okay, so one unique solution. So that's the difference. For each value of x, there's a unique value of y in this case. Okay? Then if we look at D, we see the same thing, right? For one value of x, we have multiple values of y. And in this case, for multiple values of x, we have a unique value of y, right? So you see the difference, right? In this case, the x is the one that has repeated values, and in this case, the y is the one that has repeated values. Then if we look at E, we see that, for example, here we have a circle, right? A relation that models a circle. And you see that, for example, for one value of x, let's look at -2, for example. We have one value of y here and another value of y down here. So for one value of x, we have two different values of y, right? While in this case, this is the equation of a straight line, the graph of a straight line. For each value of x, let's look at this, for example, 2. We have a unique value of y. There's no other value of y which the function is taking, right? And that's true for any value of x in this case. So that's the difference in part E. And we see the same thing here in part F. You see that, for example, let's look at 4 here. For x equals 4, we have one value of y right here and another value of y right here. While in this case, we have, for example, if we take a look at -2, we have that for -2, there's only one value of x. There's one value of y, sorry. There's not a other value of y right here. But if we take a look at y, we see that the value of y here is 3, right? The value of y is repeated, right? We have that for x equals 0, there's another value of y which is equal to 3, okay? So this is something that is valid in order when we talk about functions, okay? So the question down here says, what difference do you notice between the two columns? Basically, and let me summarize this, column 1 are not functions, while column 2 are all functions. So this was just an exercise for you to visualize the difference between a relation which is not a function and a relation which is a function. All of these examples are relations, by the way, but not all of them are functions. Only the ones in column 2 are functions. Okay, so it says the relations in the second column are called functions. So here we have the definition of a function. It says a function is a special type of relation. A function can be one-to-one mapping, which is this case over here. For each value of x, there's a unique value of y. Or a many-to-one mapping, which is this case over here. This is also considered a function. When all the values of x have a unique value, but that unique value may be repeated between the values of x. But each x has only one output. That's an important thing. Whenever we talk about a function, each x has a unique output, one single output. If x has more than one output, then we're not talking about a function anymore. We're just talking about a relation, right? So here I added the exception. They are not functions when we have a one-to-many situation, which for example is this one over here, one-to-many, or a many-to-many, which I don't think we have here. No, a many-to-many would be that, for example, if this one over here also took this value here and this value here, so it's a many-to-many relation, right? So that is not considered a function as well. Okay, so here it says, think of a function like a machine. If we put in one value for x, we want one value for y to come out each time. So here you have the graph. So for each input, I have one unique output, right? That's the concept of a function, if you want to visualize it as a machine, right? Okay, let's see this example here. It says determine whether each relation below is a function or not. So if we take a look at A, do you think this is a function? You see that for each, there's a unique value of x in each case, and for each value, well, there's a respective value of y, right? But we don't have any repetition for the value of x. So there's a unique input and a unique output in each case. They are all different. So in this case, we can say that this is a function, right? So we would say that for A, it is a function. Now take a look at B. What do you see in B? We see that, for example, the values of x here are repeated. And for each value of x, there's a different value of y. So this is a situation of a one-to-many, right? Here again, 10 is repeated and it has two values of y. So it's a one-to-many situation, right? So we would say that this is not a function. And we can add here one-to-many, in case you want to justify your answer. So B is definitely not a function. It is a relation, but it is not a function. Then, what about C? Let's look at the mapping diagram here. This is a function, right? Why? Because we have, for each input, we have a unique output. It's a one-to-one relation, right? So it is a function. We can add here 1 to 1. In part A, this was also a one-to-one situation. 1 to 1. There. Then if we take a look at D, what do you think about D? Is it a function or not? The answer is no, right? Because this is the value of x that is avoiding this to be a function, right? Because it has, for this value of x, we have two outputs, 2 and 6. So this is a case of a one-to-many, again, relation. So this is not a function. Not a function. Parenthesis, one-to-many. Okay, and finally for E and F, I want to show you how to use your calculators to graph these functions in order to determine whether they are functions or not, right? Later on, we're going to study each of these functions specifically. You would see that this is, for example, the equation of a straight line. So this definitely is a function. And this is the equation of a radical function, right? Which is also a function. So let me show you how to graph this using your calculator. If you go back to the calculator, we're here. We're going to click on exit in order to go back. Exit, exit, until you're in the main, well, well, actually you need to click menu. You can go to 1, which is the main menu. And in order to graph a function, we're going to go to menu and then graph, which is menu 5. Click on execute. Let me erase this for a second. Here and here. And we're going to plug in our two functions. The first function, here it says y equals negative 3x. So we're going to put negative 3. Pay attention when you're clicking on x. Do not click on this x over here. You need to click on this x over here, okay? So click on x plus 7, right? Plus 7. So you click on execute. And we're going to draw this function first. So just click here on F6, which says draw. I'm not able to see the function correctly here, so you can use your arrows in order to move, and you would see that this is the equation of a straight line, right? And this is definitely a function. So if we do a quick sketch of this function, we would have something like this. I'm just making a quick sketch here to avoid wasting too much time. So this is definitely a function. So let me write this. Function. This is considered a 1-to-1, right? 1-to-1. For each value of x, there's a unique value of y. And finally, for part F, let's graph this function over here, which is a radical function. So we're going to go to exit again. We can erase this or just unselect this. If you see here, we have an option. F1 says select. Click on that. And so the calculator will no longer draw this function. So we can plug in here the second function. In order to do the radical, we need to click on shift and this x squared over here. You see that there's an orange radical here. So there you have the square root of x. So we're going to click on x and we're going to draw this function. Draw. So you see the function there. If you want to zoom in order to be able to see this clearly, you can click on shift and zoom. You can click on zoom in and just click on execute. You see that we go a little bit more zoomed here. So you see that this function, or this graph, is also a function, right? Because for each value of x, there's a unique value of y, right? So this is how we graph using the calculator. So let's do a quick sketch of that function here. Right here. There. Here. And this is x and y, x and y. So the graph looked something like this, right? So this is a function because it's a 1-to-1 relation. Function 1-to-1. Okay, so that's it for this example. Now I'm going to show you one last concept before we're done with this class, which is called the vertical line test. And it says, the vertical line test is used to determine if a relation is a function. This is a very practical technique that is used in order to quickly determine whether a relation is a function or not. So look at the graphs here. We see that this, for example, is a function, basically because for every vertical line that we trace, we're always cutting the function only in one point. If we cut a function or a relation in more than one point, then the relation is not a function, like in this case, right? For example, here, if we draw any vertical line, we would see that this vertical line cuts the relation or the graph into 2 points. And if it cuts in more than 1 point, then it is not considered a function anymore, right? So this is a quick way to determine whether a function is whether a relation is a function or not. If you look at the examples we did before, you see that this is a function because any vertical line cuts the graph in only 1 point. And the same thing happens here, right? Every vertical line cuts the graph in only 1 point. So this is a function, this is not a function because it's cutting in 2 points, and this is also not a function because it's cutting into 2 points. If you remember from the investigation we did before, right here, this is not a function because it cuts the graph into 2 points, right? And this is not a function either because it's also cutting the graph in 2 points, right? So that's the vertical line test. So let's do this example quickly to finish this tutorial video. It says, Determine whether each relation below is a function or not. So if we look at A, we see that for any vertical line that we trace, we're always cutting the graph in only one point. This is the equation of a straight line, so this is definitely a function, right? So for part A, we're going to say function. Function. There. We could trace one vertical line just to prove our point, right? Only one point of intersection right there. Then for part B, what do you think? If we trace any vertical line, we see that we're only cutting the graph at one point. So again, this is definitely a function, right? So part B, we say that this is a function as well. And for the last case, well, you see that if we trace any vertical line, we're cutting the graph at 2 points. So this is definitely not a function, right? Or here, we're cutting it in 2 points. So graph C is not a function. Not a function. No, not a function. Okay, so this is how we use the vertical line test in order to determine whether a graph is, or a relation is a function or not. Okay, so that's it, juniors, for this first tutorial video. I hope this was clear. If not, please let me know. We're gonna cover doubts in future live sessions. See you.